starting a new unit of work today. We're starting linear relationships, so we're still in the algebra section of the mathematics world. Still in the algebra section of the mathematics world, but now we're sort of getting into some of the more useful functions of it, so the more useful tools that actually do help out, depending on what you are doing out in the real world. Okay? This little line here, please write this down. A linear function, it makes a straight line on a number plane and uses two variables in the equation. Alright, reason why it's two variables is because the number plane is in two dimensions. It only has a y-axis and an x-axis. Okay, so that's all we're using. There are some steps to draw linear functions. There's three main steps that we're going to use anyway. Step one. We're going to construct a table of values. So we're going to use that equation that we're given, that linear function. Alright, so equation and function are interchangeable in this instance. That linear equation, that linear function, we're going to take that and we're going to use the variables, so we're going to plug in values, create a table of values, which then gives us a whole bunch of coordinate pairs that help us draw the line. Number two. Step number two. I'm going to draw a number plane. Draw a number plane. Everybody should be able to draw a number plane. Alright. One thing to remember with number planes, the independent variable right, should be the horizontal. Alright, which makes the dependent variable, so the one that depends on what happens with this one, is then the vertical version. So we've got two variables. We have one that we can change however we like. The one that we change however we like should go across the horizontal when we draw our number plane. And the one that changes depending on that is the vertical. Okay? So the second variable will change depending on what we do to the first one. And step three is we plot our coordinate pairs. Plot coordinate pairs and we join them in a straight line. There are our three steps. So guys, in our linear relationships, when we're talking about these straight lines, we can actually write these equations in a whole bunch of different ways. The most common form that we're going to see is this. Y equals mx plus c. Now make sure you give yourself some room because we're going to make some notes about this one. Alright, y equals mx plus c. I'm hoping that you've all seen this before, at least seen it before. Whether or not you've worked with it very much is another question, but you've definitely seen it before. Y equals mx plus c. The x That's our independent variable. That's the one that we manipulate to find coordinate pairs. Okay, and we said the independent variable was the horizontal, so x is the horizontal one. Okay? Makes y the dependent variable. That makes y the dependent variable. Okay? So that's the one that goes vertically. So it changes depending on what we do to x. Alright. Now these other bits actually have purpose as well. And these other bits are going to make drawing lines really, really easy. Like so easy in fact that you won't even need to do all three of these steps. Okay? The C. The plus C. This is the y-intercept. Okay, and the y-intercept being where that line crosses the y-axis. Does that make sense? So this tells us where on the vertical it crosses. So that could be a +3, or it could be like a -4.5. It's just telling us where on that vertical line, that vertical part of the number plane, it's going across. And the last bit that we have there is the m. This m. The m is the gradient or slope of the line. So that tells us about the steepness of the line, and it tells us about which way it leans. Let's see an example. We're going to draw this line. Y equals 3x. I'm going to draw the line y equals 3x. What's step 1? What's step 1? Construct a table of values. So let's do that. Let's do it. I've got my x and my y. Okay, we've got an x and a y. I'm going to use 0, 1, 2, 3, and 4. When you do a table of values, you can use whatever numbers you want. But I will keep them fairly small, to be honest. Because sometimes you end up with really big numbers out of it. And then all we have to do is work out what y is going to equal when we substitute these values here into x. Alright, so remember at the start when we did substitution? It's essentially just what we're doing here. Okay? So let's substitute in 0, so it becomes 3 times 0. What's 3 times 0? What's 3 times 1? Yeah, so we're going to do 3 times whatever it is. So 3 times 2?
6, 9, 12. Now 1.
Okay. Now hopefully you can see a bit of a pattern emerging, because if we look really closely at this table of values, look really close at the table of values, this goes up by how much each time? Goes up by 3 each time. that pattern of what it goes up by should match whatever the m value is. Alright
So
guys?
you know you stuffed up if it doesn't.
Exactly. So you know you've made a mistake if this pattern and that number there aren't matching. Okay? So we've got that. Alright. Does that make sense?
Yep.
We good with that so far?
Yep.
Now the other really cool thing about the table of values is now we have coordinate pairs. So our first point is going to be at 0, 0. Our next point is going to be at 1, 3. Next point at 2, 6, then 3, 9, then 4, 12. So we actually have a series of dots now that we can put on our number plane. Right, so let's draw one up.
Alright. Probably very wide out.
Hopefully you're going to use a ruler to get your number plane. Something to remember. Something to remember when you are drawing up a number plane, that the distance between the numbers on each of the axes should be the same. So if I decide that that's where my 1 is, my 2 needs to be the same distance away as the 1 is from the start. Alright? So I need to be as close as possible. Alright, to keep those numbers the same distance apart. It doesn't matter if the x is different to the y, as long as all the x's are the same distance and all the y's are the same distance. Otherwise you end up with a crooked line. Alright, we want nice straight lines. Okay? And you can even do your scale differently completely in that on the x I've got 1, 2, 3, 4 to match my x numbers. And I'm going to try and match my y numbers. I'm going to make this scale go up by 3. So I'm actually going to make this one 3, 6, 9, 12, 15. Okay, because it's just going to look nicer on my graph, right? Then all I've got to do is plot my points. All I've got to do is plot my points. So 0, 0. That is the point of origin. That is where the two cross over.
Why was that funny?
Because then if you'll notice in our equation, there's no plus c part. If there's no plus c part, it goes through where the two axes cross. Okay? And then I just plot the rest of my points.
Bless you.
Alright, now if you've done it nice and straight, you've drawn everything up nice and straight, you've got your scales the same. So your x scale is all the same, your y scale is all the same. You should get a nice straight line. So again, use a ruler. Not like me on the board, use a ruler in your books. Question?
Why does the y-axis go up to 15 and the x-axis only goes to 4?
Good question, good question. So if we look at my table of values, I've used the x numbers 0 through to 4, yeah?
Yeah.
So that's what I've done on my graph, on my number plane. I've used the numbers 0 through to 4. Okay? My y numbers go up to 12. On my tiny little number plane here, I'm not going to be able to get 1, 2, 3, 4, 5 all the way up to 12. But I know that my numbers go up by 3, so I can make my y numbers go up by 3, and it'll make a nice neat line on my graph.